What if I told you that the universe might not be infinite, but instead surrounded by a wall of space-time, a kind of boundary beyond which lies a parallel world? Would you believe it? Today, I invite you on an imaginative journey, rooted in real scientific theories and mathematical models, to explore the very edge of our universe. It all began when scientists discovered a mysterious cosmic void, a region over 1 billion light-years in diameter that appears to be almost entirely empty. No galaxies, no stars, no matter as we know it. Some theories suggest this could be a scar left behind from a collision between universes, a trace of a parallel world brushing up against our own. Imagine the universe as a set of Russian Matryoshka dolls. The outer layers hold galaxies, inside them are solar systems, and within those lie planets like Earth, each layer separated by invisible boundaries. On this journey, you will pass through each of these thresholds one by one. To travel such vast distances, you'll need a fictional but mathematically plausible technology, the warp drive, a hypothetical propulsion system that allows us to surpass the speed of light. Picture yourself aboard a futuristic spacecraft. The engines ignite, acceleration begins, and you leave Earth behind. You soar past the 100 kilometers mark, crossing the boundary between Earth's atmosphere and outer space, known as the Kármán line. You are now officially in space, and you might even update your location to Earth orbit resident. Next, your warp drive catapults you through the solar system, past Mars, Jupiter, Saturn, Uranus, and Neptune. You've now traveled more than 100 astronomical units, AU, with 1 AU being the average distance between Earth and the Sun, roughly 150 million kilometers. At this point, you've reached the outer edge of the solar system, an area called the heliosheath. This is where the solar wind, a stream of charged particles from the Sun, begins to slow dramatically, dropping from over 1 million kilometers per hour down to the speed of sound, and eventually to near zero in a region known as the heliopause. Just beyond this, you begin to feel the first hints of the interstellar wind, the influence of space beyond the Sun's reach, pressing gently against your spacecraft. Crossing this invisible frontier, you officially enter interstellar space, a vast, cold, and dark region where sunlight has faded into a distant glimmer. In 2012, NASA's Voyager 1 became the first human-made object to cross this threshold, leaving the solar system behind. 6 years later, Voyager 2 followed and checked in from the same mysterious region. Interestingly, scientists discovered that the boundary on the southern hemisphere is about 10 AU, roughly 1.5 billion kilometers, thinner than that in the north. We are now approaching the outermost ice wall of the solar system, the Oort cloud. This vast spherical shell surrounds our sun, composed of trillions of icy bodies, located at distances ranging from 0.8 to 3.2 light-years from the sun, or roughly 50,000 to 200,000 astronomical units. These frozen objects are believed to be the source of long-period comets. However, due to their extremely sparse distribution, with average distances between them stretching millions of kilometers, about the same as the distance from Shanghai to New York, a probe could pass through this region safely without collision. At this point, you are utterly alone, drifting on the edge of the Milky Way, a grand spiral galaxy spanning around 100,000 light-years in diameter. With today's chemical-fueled rocket technology, traversing its full length would take over 1 trillion years, far longer than the current age of the universe. Accelerating at full warp speed, you race through interstellar space like a seasoned pilot. In just a few minutes, thanks to our imaginary propulsion, you reach the boundary of the Milky Way. Here, the interstellar winds cease to exist, and the only thing before you are distant specks of light, massive galaxies scattered across the void. It's time to unfold the map and chart your next journey toward the edge of the known universe. Currently, you're hovering near the Milky Way, part of the Laniakea supercluster, a vast region home to hundreds of thousands of galaxies. Yet even such an immense structure, when compared to the scale of the universe, is like a narrow alley in a sprawling metropolis. Zooming out further, you spot the Hydra Centaurus supercluster, containing thousands of galaxies, now appearing as faint dots on your star map. And when you expand your view to its furthest limit, you see the entirety of the observable universe, a massive spherical region from which light has taken up to 46.5 billion years to reach us. Even if you could travel at the speed of light, it would take 46.5 billion years to reach this theoretical boundary, far exceeding the remaining lifespan of the Sun. By the time such a journey could be completed, our Sun would have long since faded into darkness or exploded as a supernova, taking the entire solar system into cosmic death. And if you somehow lived long enough to complete that journey and return, you might find that the Milky Way, your home galaxy, no longer exists. According to astronomical predictions, in about 4.5 billion years, the Milky Way is set to collide and merge with the Andromeda Galaxy, forming a supergalaxy over a process lasting hundreds of millions of years. Fortunately, your spacecraft is equipped with time-folding technology based on Einstein's field equations. This allows it to bend space-time and open shortcuts, making what would seem like a multi-billion-year voyage pass in just a few seconds. And then boom, congratulations! You've arrived, the very edge of the universe, home to one of its greatest mysteries, the Great Void. Some scientists believe that the WMAP cold spot, a massive region of space measuring 1.8 billion light-years across, unusually low in temperature, may be a remnant of a collision between universes, a possible scar from a cosmic impact. A clue that our universe is not alone. To this day, the Great Void remains one of cosmology's most perplexing mysteries. It is a region of space so empty, so cold, and so eerily desolate that it almost defies comprehension. If you were to imagine this void as a cup, it would be large enough to hold up to 10,000 galaxies. The multiverse hypothesis offers a rather poetic explanation, that this void may be the scar left behind by a collision between two universes. However, most scientists currently believe it is more likely the result of density fluctuations in the early universe during its formative stages. Such models have led many cosmologists to seriously consider the idea that other universes may indeed exist. Imagine, if our universe is like a massive cosmic bubble, containing all observable galaxies and matter, then it's entirely possible that countless other bubbles exist too. These universe bubbles may have emerged during the Big Bang, each with its own composition, structure, and set of physical laws, perhaps completely alien to our own. Some of these bubbles could be parallel universes, hosting galaxies and nebulas unlike anything we've ever seen. And if the universe is a bubble, then it likely also has a cosmic wall, a boundary of space-time. Now imagine this: another universe, another bubble, once drifted close to ours. As they approached, their gravitational fields began to interact. The wall of our universe was pulled slightly toward the other, and in return, that universe's wall stretched toward us. At the moment their boundaries touched, a point of spatial connection formed, a temporary bridge between two worlds. But as the two bubbles continued drifting apart, this connection broke. The rupture left behind a gaping tear in the membrane of our space-time, a strange, cold, and empty scar. That scar is what we now observe as the Great Void. So, what about the true shape of the universe? According to the latest data from the Planck satellite 2020, the curvature of the universe deviates less than 0.4% from a flat model. This implies that even if the universe is a closed structure, its curvature radius is so enormous that it extends far beyond our observational limits. So far, in fact, that we may never reach or detect its true boundary. Now imagine living in a two-dimensional world. You would see only a square, unable to perceive its true form. But from a higher, three-dimensional vantage point, that square is simply one face of a cube. Likewise, if humans could observe the universe from a fourth spatial dimension, the square we think we inhabit could actually be something entirely different. And perhaps, just perhaps, the gateway out of our cosmic bubble, the passage to another universe, lies within the black holes scattered across our sky. According to general relativity, black holes and white holes are two theoretical opposites. One swallows everything, while the other, hypothetically, expels matter from another space-time. In this sense, black holes may not be the end, but rather the exit tunnels to realities beyond our own. The celestial object known as a white hole, in theory, is the opposite of a black hole. And between a black hole and a white hole, there may exist a connecting tunnel called the Einstein-Rosen bridge, more commonly known as a wormhole. I explored this topic in detail back in episode 26, so feel free to revisit that if you'd like a deeper understanding. Some astronomers believe white holes may indeed form, but because they are so unstable, they are likely destroyed almost instantly after appearing. The entire process bears a strange resemblance to the birth of the universe itself, the Big Bang. As a result, scientists have coined the term Little Bang to describe it. Here's a view of Earth, our home, and its natural satellite, the Moon. Zooming out, we see the solar system, a tiny planetary system surrounded by countless stars. Zooming out even further, we reach the Milky Way galaxy, home to hundreds of billions of stars, with our sun barely a speck among them. Expand your vision once more and you'll see galaxy clusters, vast regions where thousands of galaxies swirl together, glowing like spiraling lights in the vast cosmic darkness. Farther still, we encounter Laniakea, a supercluster where the Milky Way is but one among millions of tiny galaxies. Then comes Hydra Taurus, a region filled with thousands of massive galaxies, now appearing as tiny shimmering dots. And beyond that is Pavo Indus, a cosmic stretch spanning 200 million light-years. But viewed from afar, it's just a faint patch of light suspended in the pitch-black void. Finally, when you zoom out as far as human science allows, you behold the entire observable universe. Here's the miracle. Every single tiny point of light in this map contains thousands of galaxies, and each galaxy holds billions or even trillions of stars. Many scientists now believe the universe may be like a giant bubble, and it may have once collided with other cosmic bubbles. This has led to growing support for the theory that the multiverse may be real, and that there could be an infinite number of universes, all born from the Big Bang, and some perhaps having interacted in the distant past. One possible piece of evidence lies right here, the Eridanus supervoid, an enormous empty region spanning 1 billion light-years in diameter. To grasp its size, the Milky Way is about 100,000 light-years across, making the Eridanus void 10,000 times wider than our entire galaxy. It is nearly completely empty, no galaxies, no matter, just absolute darkness and freezing silence. Some scientists believe it may be the scar left behind from a primordial collision between universes. They propose that when two universes came extremely close, like two drifting water bubbles, their gravitational fields began to influence each other. The space-time membrane of one universe was pulled toward the other, and vice versa. Just like two drops of water that try to merge but move too quickly to stay connected, the result was a violent tearing of our universe's space-time membrane, leaving behind a vast, dark, and frozen scar, the Eridanus supervoid. Within that immense emptiness, the Great Void, there may once have existed around 10,000 galaxies. But now, they are either completely destroyed or have been devoured by another universe. Let us now imagine, through a hypothetical simulation, how a collision between two universes might unfold. In a different dimension, in another universe, we witness nebulae of dazzling shapes and colors glowing in the darkness. But as we turn to face the other direction, we see a massive wall approaching. Upon its surface, every glowing point is a colossal galaxy, rushing toward us at unimaginable speeds. Yet this is not a wall of matter in the traditional sense. It is, in fact, a giant mirror, reflecting our own universe back at us. At the boundary, space-time begins to bend violently, being stretched and sucked into another universe at phenomenal speed. In this region, the physical laws as we know them may cease to apply. Gravity may vanish. Stars may erupt. Entire civilizations could be cast into zero-gravity chaos. But if the two universes don't merely brush past each other, if they collide head-on, the consequences could be far more catastrophic. Such a collision would unleash tremendous energy, possibly triggering a second Big Bang, not one that gives rise to life, but one that obliterates the entire internal structure of our universe. Alternatively, the two cosmic bubbles might begin to merge. At first, all the galaxies at the edge of our universe would be torn apart by the fierce gravitational interaction. Then, the process of unification begins. Galaxies spiral chaotically, passing through one another, colliding, shattering, and erupting like fireworks in the silent dark. You drift through the cosmic abyss, surrounded by stars and galaxies. A vivid nebula collapses in front of you, about to explode as a supernova. You quickly steer your ship to slingshot around a nearby black hole, cautiously avoiding its deadly pull. One wrong move and it will consume you like a cosmic beast, leaving behind not even a trace. Wait, what's that ahead? A glowing structure. It's a wall of light. If you look closely, each speck on its surface is a fully formed galaxy. This wall contains up to 100,000 galaxies, and each one, like the Milky Way, contains around 100 billion stars. That means this structure could harbor quadrillions of stars, many like our Sun. This enormous formation is known to scientists as the South Pole Wall, a cosmic megastructure stretching 1.37 billion light-years in length, located some 500 million light-years from Earth. Astronomers discovered it by analyzing redshift data in the spectra of galaxies, allowing them to map their distances and motion. But here's the intriguing part. You can't actually see the South Pole Wall, not even with the most powerful telescopes. Why? Because the Milky Way, our own galaxy, lies directly in the line of sight, and it is too bright. The light from its hundreds of billions of stars obscures the view, casting a veil over the space beyond. And so, the South Pole Wall remains hidden in invisible darkness, concealed behind our own galactic glow. Scientists discovered the galactic wall using redshift measurements, a technique that allows them to track the motion of objects across the universe. Since the Big Bang, everything in the cosmos has been moving outward in all directions, and light waves emitted by galaxies shift as they move. By analyzing these shifts, scientists can determine what an object is and how fast and in what direction it's traveling. Yet surprisingly, the South Pole Wall isn't the largest structure we've discovered in the universe. That title belongs to the Hercules Corona Borealis Great Wall, a colossal, flat superstructure spanning nearly 10 billion light-years. This wall, like others, is formed from a chain of galaxies held together across unfathomable distances. It was detected through the observation of gamma-ray bursts, some of the most powerful and luminous electromagnetic events known in the cosmos. Within this immense formation, scientists identified at least 73 quasars, which are among the brightest and most mysterious objects in the universe. These quasars are actually the active cores of galaxies, fueled by supermassive black holes, some of which, in this structure, are believed to be 800 million times more massive than the Sun. All these immense structures are considered the basic building blocks of the universe. Zooming out from our own solar system, we see these galaxies form long, interconnected filaments that are separated by vast regions of nothingness. These desolate areas are called voids, nearly empty spaces in which almost no matter exists. One such void is the Eridanus supervoid, also known as the cold spot.